why I know nothing about the quantum, because it was. All right. Okay. Here's one, Neil. This is something that we have talked about in the past several times. And the fact that it is real is just very difficult to wrap my head around.
Okay.
And that is, we have kinematic time dilation, we have gravitational time dilation, and these are not perceptions. Because you told me about the atomic clock experiment. And so the atomic clocks are the most precise chronological measurement of time, and we end up with different readings in these experiments. Is time real? Is it a thing? Is it even a thing? Is it even a thing for real? I mean, come on.
Chuck is blowing a gasket.
I'm serious.
Chuck just blew a gasket. Okay.
Are humans the only species that kind of measure time? Or
no,
quantify
turtles do. So, for example, you've heard of half-life, right?
Yes.
Of course.
Half-life, okay. At half-life limit, let's make sure we're on the same page. There's certain elements that are radioactive, which means they decay into different elements. Right. You start with a blob of one element, and if it has a half-life of a week, let's say, that means in a week, on average, half of those atoms will have turned into a different kind of atom.
Right.
Yeah.
They would have decayed. And then in another week, half of what remains turns into it. Okay, it's half of a half of a half of a half. And it drops rapidly. It's 2 to the n power, right? So it drops rapidly. Okay. So if you have 10 half-lives, then you have 1/1000th of what was there before left over. Because 10 is it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2, and you get 1024, I think. Right. So it's basically 1,000th of what was there. All right. You can take an element that has a half-life and accelerate it to near the speed of light, and its decay will be delayed by the exact amount that you calculated in Einstein's relativity. And it's not carrying a Timex with it, okay? Or a Rolex. It's whatever internal clock tells atoms to decay, that is affected by relativity. So time is real. Relativity is real. Now, one way to think of it, which Jan 11 has tried mightily to get us to understand, all right? If you have two axes, okay? And one axis is distance, and the other is time. Okay? Not distance, it's just space. One is space, the other is time. And they're like right angles to each other. All right? So it's two axes. Now, if you're sitting there going nowhere, you are not moving on the space axis, but you are moving in the time axis, aren't you?
Yeah.
Time is going forward for you.
Right.
Because your lazy ass is on the couch and you're not actually moving anywhere. Okay? Okay. So if you start moving, then the line on this graph that applies to you is not the one that's going straight up the time axis. Because now you are moving from your previous location and now you're in a new location and you're continuing to move. So now as time progresses, you advance a little bit in the space direction. So you have a line that's at an angle right now from the vertical. Can we picture this in our heads?
Of course. Yeah. Okay.
You got it. Okay. Great. So now, Chuck, you've been slow lately. Gary's a former ex-pro footballer. He's going to run while he watch you walk eating potato chips. Okay. He will run. You are both moving forward in time. Yes. But he's moving farther in distance than you.
Right.
In the same amount of time. So his line will be at an even greater angle than yours will. Okay?
Right.
We got this?
So far?
Yeah. Mm-hmm.
Okay. Now, everybody's got to measure the speed of light to be the same. This is one of the great insights that Albert Einstein had in his relativity. Okay? In order for both of you to measure the speed of light to be the same thing, your time coordinates
Have to change.
have to change.
His
Correct.
would have to slow down in order, if speed of light is a constant, his time, which is that, because the speed of light's got to remain the same.
Correct.
So that means his time would literally have to slow down in order for him to observe me eating the
time that you
at the
correct.
same time. Jesus Christ. See, this is what I'm
Right.
talking about.
What?
We're both seeing the time. The time slows for him, but it's the same for me because the speed of light is time is bullshit, man.
Chuck.
It literally slows down for him. Literally.
Yes.
It is not like it's a perception. The
No, it's not
time
perception.
itself
Everything,
slows for him.
his metabolism, his thoughts, his any radioactive material he's carrying in his pocket, his clock, everything, the vibrations of the atoms, everything.
And referentially, for me, everything is exactly the same for me. My time is staying the same for me, okay? But for him to observe me, his time actually has to slow down in order for that observation to
Wait, no. So to be more clear, you're watching him.
I'm sorry, I'm watching him. That's what I'm
You're
I said.
watching him.
I didn't mean that. I said it
Right.
backwards.
And so so start that.
Go ahead.
So you're watching him, and from where you are, you both want to measure the speed of light to be the same. But
Exactly.
the only way that can happen is if you see him move slower.
Right.
That's
He's
correct.
got to move slower because his time,
Correct.
and it's not like I'm perceiving him to move slower. His time literally has to slow so that he can
Make the same measurement.
Make the
Correct.
same measurement that I.
Correct. Okay. Now, as you go at the speed of light, time stops. So that would be that would be a line moving along the distance axis, but not advancing along the time axis. It would just be flat line there. And so therefore a beam of light can get between any two places with zero elapsed time. So a photon particle of light emitted in the center of the galaxy, which was the object of my affection for my PhD thesis, the galactic center, those photons, I will see them travel for 30,000 years, but if you're that photon, you don't live for any time at all.
No time.
That's right.
There's no
You
time
are detected in the same instant you are emitted.
Right.
Correct.
Okay.
Right, so you got to get Chuck off the ledge there.
It's crazy. This is, I mean, and seriously, it's so funny because it's okay, forget it. It is mind-blowing that, that these are, for the measurements themselves, these are true measurements. You would think that these would be perceptions because you're talking about it being relative to an observer, but they're not perceptions.
Yeah,
They're
in fact, observer is an unfortunate word that we still use today.
Yeah, we still use.
We refer to observer and a phenomenon,
Right.
and people then think it's something to do with you for being human.
Exactly. No. Right. And it really isn't. These are actual measurements.
Correct.
And the measurements themselves are true and correct as they relate to the time and the constant being the speed of light. That's insane, man.
Yeah, it's crazy.
It's just crazy. It's crazy.
Yeah. And another example, we've given it before, but now we have our own private burning question session here, that this phenomenon occurs in the strength of a gravitational field as well.
Right.
So the stronger is the gravitational field, the slower your time moves. So our GPS satellites, fly in MEO, right? We have LEO, MEO, and GEO, right? So MEO, middle Earth orbit.
Right.
And so those are like 12,000 miles up. And so that's high. Okay. Yeah. That's farther away than the diameter of the Earth is above the Earth. So they're far enough away from Earth's center that the difference in timekeeping for them is different than it is for us.
Right.
Okay, so their clocks, since they're farther away from it, are moving faster relative to us.
Right.
So when they keep track of time and send us the time, we have to correct it, because we care about the time in our reference frame, which is Earth's surface.
Okay. So who calibrates this? What calculation are they?
We got people. That's why there's a National Bureau of Standards. I mean, they're people who think, you got to be glad they're there, and they're the unsung heroes. You don't even know they're there, and they're figuring this out for you. So, and let me tell you how deep it goes.
They all use the Timex.
Okay. So what? How deep it goes. So, we're on Earth's surface, and we think of it as just one surface. Right. But there's something called the geode. And the geode is the grid that the GPS satellite is actually talking to. Now, in that grid, is the geode you're using for Earth a perfect sphere? Okay, that's a model of Earth's surface, but that's not Earth's surface. Earth is wider, slightly wider at the equator than it is at the poles. The equator is farther away from Earth's center than people not on the equator, which affects which time frame you are in relative to the GPS satellites. So, if you want to be really, 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 really precise, you have to know where you are on the geode relative between the perfectly spherically modeled Earth and the Earth that's slightly wider at the equator than at the poles. And by the way, we're not only an oblate spheroid, slightly wider at the equators than at the poles, we are slightly wider below the equator than at the equator. So we're a pear-shaped oblate spheroid. And that's harder to model mathematically. And usually you don't care about that level of precision. So typically they just use a spherical approximation for Earth's surface and let the dust fall where it may.
Mm-hmm. Are we talking nanoseconds here? Or
no, we're talking about you're one doorway away from where you had intended to be, that sort of thing. But you're usually tracking down an address. And so once you see the address, you're not still using GPS to decide that. You know who needs these coordinates? The military. Because if they're sending a missile via GPS guidance, you don't want to make
a difference.
Yes, the doorway to the left or the right makes a difference.
Yeah,
right. So they have to know what the exact shape of the Earth is at the point where they're interacting. And of course, GPS was invented by the military, by the U.S. Air Force, now under the control of the U.S.
Postal Service. They don't want to get the wrong mailbox.
He's a Brit. Well, excuse him on this one, Chuck. The GPS was designed and built by the military, and it was controlled by the U.S. Air Force until it is now under the control of the U.S. Space Force.
Oh, you know why? I have never accepted Space Force.
Oh,
that's why I was wondering. I was like, why am I not getting this?
And Chuck, I cannot begin to tell you how irrelevant that fact is.
I know
to the world.
I know, and I need to
you don't accept it,
and I need to get over it because guess what? And I just felt. First of all, I thought it was a dumbass name, and
what? It's space and it's a force. Wait, dude, calm down.
Because listen, we already
have
the Air Force, and then you're just gonna
hold on.
And now we're gonna make it Space Force.
Okay, hold on. Okay, so we still have the Air Force.
Yes,
they worry about the air. Okay, Space Force worries about stuff that is not moving through the air. Okay, those are called satellites and other rockets. All right. Did you complain in 1947 when the Air Force split from the U.S. Army?
Well, no.
No, because you weren't born. But had you been around, would you be imitating who was president in 1947? Who was it? Truman? Would you be imitating Truman and saying, "Well, why have an Air Force when we have the Army?" who
Air
can
Force.
fully take care of the Air Force.
Air Force
The Army
sounds
has
cool.
soldiers on the ground with
Because Air
tanks.
Force sounds cool. It sounds cool. Truman had it right. It sounds
Okay.
cool. To,
I-
where
I'm
Space
just-
Force sounds like something that
Science fiction-y.
that Seth MacFarlane came up with. That's what Space Force sounds like. It sounds like Seth. They were like, Seth, we need a name. We need a name for an organization that's going to put us out in space and take care of all of our space related. How about Space Force? Let's go with Space Force. Like, no.
So the entire space branch of the Air Force basically pulled away to become the Space Force, where command and control is different. All there's so much that it's maybe not entirely as different from the Air Force as the Air Force was from the Army,
Right.
but it's different enough to justify its own branch. And now they have a seat at the table in the Joint Chiefs of Staff.
Yep.
Gary, we got time for only one more burning question, but it can't just be any question. It has to be burning.
Okay. What is the one scientific breakthrough for you that has shaped the world the most? And maybe what is the next one for you?
That has shaped the current world?
Yeah.
The fact that matter is made of atoms, and atoms are made of particles.
Really?
I don't think anything has shaped the world more than that knowledge and awareness.
That's a really cool answer.
Because that's what gives us electricity.
Yep.
Yeah.
It gives us the nuclear power.
All of our communications.
It gives us our understanding of molecules, how and why they work. It gives us our understanding of the periodic table of elements.
Yep.
Why is it periodic? Okay. All of that comes from that fundamental realization. Because think of it, before then, it's like, oh, I'm a woodcutter. I just care that my wood atoms, you'd say it's atoms? Okay, I got wood atoms. Fine. I don't care. I'm just going to cut. Okay. Oh, but wait a minute. When you burn wood, what happens? Oh, there are molecules there that have energy that break apart. Okay. So there it is.
Yeah, that's a really cool answer. I would have never thought of it that way. But yeah, that discovery changes everything.
And if I can tell you one other thing, there's some professors at MIT who created a course called Energy, and big fat textbook. Everything you ever wanted to know about energy. Machines, the conversion of energy from one thing to another. This goes on and on and on. And
how I can get more of it in the afternoon because I feel so bad around 2 o'clock.
I don't know if they get the caffeine energy.
Oh, they don't
going
get to that? Okay.
Right.
No.
Wait, so let me get the book. Hold on a sec. Here's the book. The Physics of Energy. Okay. Robert Jaffe and Washington Taylor. Okay. 2 professors. And look how fat the book is.
All right.
And so I want to read to you my I wrote a blurb for it. Okay?
A blurb.
Here's
Is that
my
a technical term?
Yeah, it's a total technical term. Here it
All
is. You ready? And I pride myself on always having the shortest blurb. But this one is about the same length as the others. Okay, so here it goes. Ready?
Mm-hmm.
If your task was to jumpstart civilization, but had access to only one book, then The Physics of Energy would be your choice. Professors Taylor and Jaffe have written a comprehensive, thorough, and relevant treatise. It's an energizing read as a standalone book, but it should also be a course offered at every college, lest we mismanage our collective role as shepherds of our energy-hungry, energy-dependent civilization.
Wow.
And then they inscribed it to me. There's a little inscription there. I'll read that to you.
Look at that.
All right.
Dear Neil, here's hoping we don't have to jumpstart civilization anytime soon.
How about that?
Oh, that's very funny.
So I would say a close second to knowledge that there are particles is the fact that we have learned to understand, measure, harness, and transform energy from one form to another. That, in fact, is the backbone of modern civilization.
True. Good answers.
My
man.
question got a great answer. Thank you.
Yeah.
Oh, no. Or was it just a great question? And I gave an average answer.
Take credit, Gary.
Take it where you can get it.
I'm taking and running. I'm running.
All right. Well, I enjoyed this. Get my co-hosts, giving them a chance to ask burning questions. We might make this a regular thing. I don't know. But you have to earn it. We got to get through many other episodes before.
We can't make them too regular. There's people who pay us money to ask
to
questions.
ask their questions, right?
Ask their
Yeah,
questions.
we're gonna get into the lobbying business.
All right, Gary. All right, Jack. This has been Star Talk. Neil deGrasse Tyson here with burning questions from Chuck and Gary. As always, I bid you